here we are.
I feel like I never left.
Eric, that's every show. It's just a continuation, right? Like we just took a quick break and now we're back.
I know. If someone's out there binge watching us, we don't leave. We just go off set, change shirts, come back. So
that's exactly it. We film everything like a regular TV show well in advance, all at once. Just kidding. This is live.
And it's live because of literally the blog post landing like a half hour before this episode is going live. So
that's right. I mean, how great is that? You want current information, come to Containers from the Couch.
Yeah, and if you're curious what blog post Justin just referenced, it is the blog post regarding AWS controllers for Kubernetes that Michael Hausenblaus just posted. We are live. Someone had asked, are we live? We are definitely live.
It was all a joke. Alan-san. Yes, we are live. Absolutely. Criminal Minded Brooklyn. Wow, we got some new visitors. Yes. I don't recognize these names. So yeah, we're absolutely live. Welcome to the couch.
Yes. And well, I guess since there's some new people, this is Containers from the Couch. And I think it's always good to introduce ourselves. Brent, were you saying something? Because I saw your mouth moving, but I didn't hear you.
Well, so I think my browser froze up for a second. Now it's back. So go ahead. If that happens, then, I'll just go to sleep.
Just keep going. All right. That's fair. But yeah, so we talk all things containers here, containers on AWS, but oftentimes it's not just limited to, exclusive AWS. Like, for example, yesterday we talked about Bottle Rocket, which is a container focused operating system.
Yeah.
And, Justin led us through a really great walkthrough in using Bottle Rocket. Of course, if you've seen any of Justin's talks, he loves props. So there were some props involved. And if you haven't seen, I recommend it was yesterday's show. So containersfromthecouch.com. And then you can find the show from yesterday. But
I don't know what you're talking about, Bottle Rocket. I was just eating lunch and just talking about a normal conversation that I normally would have. Lunch for me is, some mixed nuts and stuffed animals and some donut holes. Yeah, I don't eat the Tide Pods, but, it's...
Okay, good. Not anymore anyway.
I did feel like we had to say that, so I'm glad you said it.
Yeah.
You don't eat Tide Pods, so don't do that at home, folks.
Or anywhere.
Good point. Good point. It's not limited to home. It's everywhere. Don't eat Tide Pods. Bad move. But one thing I was thinking about is I always, as someone who's built and managed, environments in production, for startups and large companies, I've always tried to find ways to kind of abstract the level of management that I need, in the stack. And yesterday we were talking about Bottle Rocket, which I think eliminates a lot of the heavy lifting from a security perspective of managing a full-fledged Linux, operating system where you have to think about packages and upgrades to your packages. And then today, we're talking about the AWS controllers for Kubernetes, where again, we're abstracting the management of the underlying resources in AWS one level higher, right?
Yeah.
And I know we're going to talk about it, but Brent, you were just talking earlier about kind of the different levels. Do you want to maybe talk about that?
I think, actually our colleague Nathan Peck tweeted about this and maybe blogged about it, but he came up with a really great concept when it comes to comparing infrastructure as code. And one of them is just, setting levels for the various options that you have. So you can start off level 1 type infrastructure as code might just be, some shell scripts that fire commands at an API or something. Level 2 is probably like Puppet, Chef, Terraform, Ansible, Salt. Those are all things where you define step by step all the details necessary to get from point A to point Z. And then there's level 3, which is just define the end state that you're looking for. And something else has all the logic necessarily already baked in to reach that end state. So that's what we're starting to see a lot more of. We see that with CDKs. We see that with controllers in Kubernetes. We see that with the Kubernetes control plane, the ECS control plane. Just all of these orchestrators and things like that come with baked in intelligence that get you where you want to be, and you just describe the end state that you're looking for. So I think, what is a controller is probably the best thing to talk about at this point, because we're releasing controllers for Kubernetes. But what is a controller, and why is it considered infrastructure as code? Maybe.
Yeah, and I love that analogy of like those levels, which is literally like the demo I was kind of walking through today of.
I'm sorry.
Well, no, like that's great, because like it's reinforcing the exact same thing that like making, like when I think about it, like what was my learning path to using any sort of technology is typically like I've always said that I do it once in the GUI, and then I do it once at the command line, and then I try to actually automate it. Like I need to learn like the workflows of what I'm doing and some of the options, and you won't discover that sometimes at the command line. You won't discover that in a declarative, text file. But doing it in a GUI does help learn a lot of those things. And then figuring out that workflow of like, okay, I had to create this thing first and then this thing. And then when you script that and you go through the imperative steps, like that helps you understand like what's going on. And at some point you say, like, I don't want to have to like script this. I have failure pieces. I need to share this with someone else. And so that's where it really like that declarative state gets a lot easier to maintain and manage and share and tell people how it works, and also update and change if your default policies are going to be different next month or next year. You don't need everyone to go, oh hey everyone, like don't run that command anymore, you have to do this other thing. It's like no, like I handle it on the back end and people talk to my API or they talk through a standard interface.
Right.
So I think and we are kind of evolving the original thought around cloud formation, right? Infrastructure as code. So that's all what started it, and now we are seeing layers above that. Yeah. So I think this is a great, interesting development around ACK and how we manage AWS resources from the Kubernetes language.
Yeah, totally. When you think of infrastructure as code, also though, like I kind of equate it to back, when I was working at the various startups that I would work at, we would oftentimes have dedicated teams, like for databases. We might have a database team, MySQL team, whatever, and you might go to them and say, hey, we need to do a master promotion of this shard from A to B or something like that. You just tell them, right? You declared the end state that you're looking for, and they have the intelligence to go off and they know what to do to make that happen. And their process might change over time behind the scenes directly to what Justin was saying, but I don't have to be aware of that. I still just declare the end state that I'm looking for. And so I think at this point, what a controller might do for us is, in effect, take that human knowledge and automate it or bake it into a dedicated set of functions or processes that the controller comes with and knows about, and I don't have to then know about it or write it myself.
And that even gets to another point of I think it's Charity Majors always says that tools make borders. Like that's where like the tool I use to do something is where my like interface stops with the next team. And so if I'm using Puppet or Chef and they're using MySQL, like their CLI is different than mine, and like I have to go talk to someone. I have to do that. I have to go have that interface, that interchange with someone, and say like, I don't understand this piece. Please just handle it for me. And that's actually one of the best things about doing these controllers inside of Kubernetes, because Kubernetes is becoming a universal control, like API, CLI and control plane for all of this stuff. And so the tools are getting merged, and that's also collapsing some borders around where the team like, oh, I don't manage that anymore because I didn't do that database. But if we can manage infrastructure with the Kubernetes API and manage our applications and manage, IAM permissions or RBAC or whatever it is within the cluster, everyone uses kube control at that point, kube cuddle, whatever you want to call it. They interface with the Kubernetes API, and those borders start to disappear because the teams have a common ground and a shared knowledge of, oh, this is how this should work. I can now do that, or it empowers those teams to do it themselves.
That's such a good point.
I was waiting to hear desired state, but I think, that ultimately the controllers are going to meet desired state, right? You've declared your state. This is my desired state. The controller ensures that you are in fact meeting that state.
So let's even just to show an example for some people. I have a couple directories here of just like what I kind of think of when I think of infrastructure as code. We have like the bash example where if I go in here, I have this deploy script, right? Like originally I was setting up, infrastructure. I just wrote it in bash, and it's probably just going to do something really simple. It's like S3, make a bucket, and I'm going to call it containers from the couch bash buckets. And so if I deploy that, like something should happen at some point. Okay, cool. Like I got some outputs, but if that fails, like I have to figure out, I have to clean that up somehow. I have to know what I'm doing to get
why it failed, how it failed, what can you do about the failure, and also what if you ran it again right now? Would that cause a failure the next time around?
Right. Item potency, right? Like those are all these things you have to consider.
Yeah.
Right. And so, hey, look, I already have that bucket. Like I can't run it again. Okay, well now is this okay? Is this not okay? Is this an okay failure state? And those sorts of things for getting started are critical. And how I don't want to do this imperatively, because once this gets complex and I do 5 steps, okay, which step did it fail on? Do I have to roll back the other things? This is where databases have been doing this for decades, right? Commits of hey, I want to do all this stuff, and now I'm going to commit it. And if you fail, it's one thing, and we just roll back the one thing. It's not how far back did I need to go. So yeah, it's definitely bash getting started. It's like infrastructure as a CLI or infrastructure as commands. It is still a human that kind of drives that, and the human stores the state. There's no state storage here. There's no I am the state store for this script. And if I go to a team, if it's just me, we're probably okay. But once I have someone else I'm working with, hey, where's that state stored? Who ran it last? Who knows what the error was? That state storage becomes difficult because I can't manage that in technology. It's in people.
Yeah, I really like that. That's such a good point.
And so for me, my progression was I kind of go from this bash, and then I went to Terraform for a lot of stuff that I was working on. And so when I think of Terraform, it's what do I call it? Deploy TF. So I have basically the same thing, a declarative, hey, Terraform, I want you to make a bucket for me. And I'm just going to call it containers from the couch TF buckets. And so I can TF plan. And this gets into a different workflow. This gets into hey, I need to check if this is going to be okay. Is this going to work? Yes or no? And it's oh, cool. This is what it's going to do. And it gives confidence to the user to say hey, yeah, I think this will work. We're going to be okay with this. Mm-hmm. And then I can, of course, apply, wait for it. It's going to do that, check again and plan. And
it's going to check state, right? It has a state file.
And so that's where,
it solves some of the issues that Justin was talking about with managing state. Also, what you mentioned, item potency. If we did it again, then it would just check. It would see that it's there, and it wouldn't act again. So it's definitely an improvement over a bash script. But it also comes with some problems, right? You have to go learn Terraform.
It's not an abstraction layer. It's not it's not necessarily something that makes some of these things easier. And it's still a border boundary where this is typically someone that manages infrastructure is going to be using Terraform, but the application developers aren't necessarily deploying their applications with Terraform. Maybe they are. I don't typically see that places, but Terraform can do a lot of things. There's a Domino's pizza provider. I can order a pizza with Terraform, and that's a thing that exists. And if I want to do that, I can. And it shows off some of the power and flexibility of what Terraform can do. But you're right. It's not. There's still this notion of it's code that sits in a repository that doesn't run. It's code that, infrastructure as code isn't beneficial once my state drifts. Once I go into the console and change some things, and then Terraform's well, I didn't manage that piece of it, so I don't is that okay? When is this going to get applied again? This will only get applied if someone runs Terraform, and typically that's like a CI/CD pipeline. So if no one touches this code for a year, but someone has been messing in the console for a year, like at some point you're going to have to merge those changes, and that's like kind of critical. And Terraform is great at that. Terraform can do those things for you, and even you know, I can have remote storage for the state storage. I can work together with this on a team level, and it makes the plan outputs and the apply output so much better than doing these in bash scripts.
Totally.
And it's really like, I mean, the same thing with, you know, CloudFormation and the CDK. CDK basically boils down to CloudFormation. It's essentially a server-side Terraform for AWS, where if I don't need to, I'm not running the command line, you know, to deploy this and to figure out that state. CloudFormation can do it. But again, if you're not doing that reapply, if you're not always looking at what is the current state, where should I be, that gets difficult.
But to your point, Justin, we need, I mean, what ACK provides, in my view, is that single language which customers need to learn, where I think there is an adoption curve around something like Terraform or CDK with Kubernetes and the YAML and the languages which we are using. ACK can provide a single form of interaction. So that's very interesting.
And in ACK, there are the AWS controllers for Kubernetes, ACK, whatever you want to call it. That piece of it, it's not necessarily abstracting the stuff still. It's adding a management layer to these APIs, just like Terraform does, where we can declare things. So if I go in and deploy Terraform, I want to say this is supposed to be a version. I think that's the term for it. I have to look this up real fast. Doing it live. You know, I remembered it yesterday, and then I just completely forgot this morning. So, of course.
And by the way, this is really one of the benefits of watching this show is, you know, we do things live, and that means we have to read the docs sometimes and try to remember, you know, what we did earlier the other day. And so it's,
and I had it wrong.
Cool to see. Yeah. It's cool to see the thought process too.
Yeah.
I run on a plan now. I should see some sort of modification here, which is, I did it wrong still. Oh, that was a nested argument. That's not. You just go right to these examples at the top and just copy paste from that.
Yeah. Brent does appear to be frozen, but your voice is coming out. It's like ventriloquism.
I know. This is my Mac at work or not at work or app working. Sorry. I'll unfreeze in a minute.
We'll get you back in no time. There we go. But I do think as Justin's working through this, I think you're kind of driving the point here that, you know, the team managing the Terraform configurations, while I think HCL, the DSL, the domain specific language for Terraform, I do think is pretty easy to read and work with. It still requires you to have to understand Terraform as well as everything else that you're working on, right? So if you have Kubernetes, you have to understand Kubernetes manifest configurations and Terraform configurations. So, and
I still broke it. I actually realized that I did all this work on a different system, which is awesome. Oh wait,
it's amazing.
Here we go. Let's get over there.
Wow, Justin, between the props and your shell terminal, like it's just always
this is wrong again. Sorry,
wrong box. Okay,
I got it somewhere, but I wanted to go like straight from Terraform into like what's a controller, right? Like what is the difference between, okay, I have this infrastructure, this repository of code, and how is that different than a controller? And what does a controller do, and why is it different? And I think of it as like the term GitOps is similar to this sort of controller where I have this repo of code and I need it to be something that's running. And my initial step was actually where my prop comes in. And it literally, like, everyone was on the call, like it just came in the mail, like not even 10 minutes before this. So we're unboxing while we
Yeah,
unbox.
I still don't even know what it is. It's a surprise.
Oh, you know what? It's in a box again. Where's my? So we got this little thing, which is
a container.
It is a container. It's a container in a container. And the funny thing is like I'm gonna get all the way to this box. And when I was telling Adam this yesterday,
Everyone's intrigued.
I know.
you got to have some.
It's the reason Anton tuned in.
So I got a box, right? Like I unboxed a box, but what does this box do? Like, why is this different than something else? Oh, I can't even get to the batteries. Well, I realized
there are batteries.
Yes,
Wow.
There's batteries. I actually realized ahead of time that I was like, I'm going to need batteries for this, and I grabbed them before this stream so I wouldn't have to leave. I was prepared.
We've stepped it up from Tide Pods.
Yeah, you know. Okay, I think that's it.
Yeah, I got to tell you, I think Anton is getting. I think he's
There's
on
no
to
other box in here, but
So-
this to me is what a controller does. Anyone recognize this?
No.
It's called a useless machine, and so what it does, this is what a controller does in your infrastructure. When you have a controller in Kubernetes, this is what it does. You say, I want my desired state to off, right? And this is my code says desired state is off. And once someone goes in there and monkeys with the like config or infrastructure or something in your infrastructure, did you catch it? It's like immediately like turns it back off. Like the little arm pops up and it's like, no, that's supposed to be off. Like I am reverting that right now. And that is what a controller does. That's what Kubernetes controllers do in your infrastructure. It's no longer a repo full of code that just, figures out like, oh, well, once I'm deployed, once Jenkins runs me, then I will figure out what to do. Kubernetes controllers are always running. In my book, this is what Chris and I dubbed infrastructure as software. This isn't a repository of code. This is running software that takes data. It takes some sort of spec and it says, hey, from this spec, what should the desired state be? And so at that point, you're not manipulating code anymore. You are just implementing the data, which is the data is your desired state. And the running software, the infrastructure as software, does that every time. And it's just like, no, I wanted 10 pods. No. And it's like, no, it's off. Like, that's what we need to do. And that's where I'm glad you like it, Brent, because like, that's just like, as soon as I thought of it.
This is genius. This is such a great example. And that's exactly what it does. Like, if you come along and you mess with it, it comes along like microseconds later and fixes it for you.
And that's what, like even we can do this with Terraform, right? We can have a Terraform controller. I could say, like, I have my repository here of Terraform, and I even have a deploy TF. That was just, no, that's a deploy SH, which is just like, while true, run this Terraform code over and over again. So I can say like deploy sh, and I can say, hey, applying Terraform. It's just gonna every time just apply the Terraform. This is I got hold on. Let me fix that. We can say it's just going to apply Terraform. If you don't know, also like yes is a super awesome command line tool. It pipes Y out to something, and so you can give it a string, and it'll just say yes every time. So like it'll accept your Terraform. It's going to say, hey, Terraform's every 10 seconds. I have a sleep in here. It's going to apply this. It's just going to sleep. Okay, we're just going to apply it again. This is essentially the same thing, right? Like, I want that bucket to exist every 10 seconds. It's going to say like, yeah, we're going to just reapply. And Terraform's smart enough, not like it's still going to figure out state. It's still going to do these things. So how can we do this better? How can we say like, well, I don't want like my controllers having to sleep, right? Like that's not great. But we could like, even in Linux, you can do it with other things. So there's I notify wait.
Yeah.
And so we can say like, hey, if a file changes, like then I want you to do something, right? Like, so we're going to say modify, now let's just say, let's see the commands here. So we have set, and we're going to say yes. Right. So this is going to say anytime a file is modified in my directory, I want you to run this command for me. Oh, where'd you? Oh, I wanted a while to on it. So it's going to say, okay, now we're watching this directory. Anytime, oh, too many shells. Get back to that. So now if I'm in my directory and I say, okay, it's watching, it's just looking for any file. We're going to run Terraform apply. So if I come in here and say, change my Terraform spec, I don't even need to like modify it properly. Like I could break it and this script is going to start failing. But even if I add a new line, right, it's still going to do the same thing. It's not super smart. So now, hey, you modified that file. We're going to apply it for you. And that's what a controller is. It's doing this watch. And so it's not a dumb, like just a sleep, run on a cron. It's not that sort of thing. And it's not a git commit necessarily. And that's what Kubernetes controllers are doing. They're watching the API and they subscribe to certain events for objects. And so what ACK does is it creates those objects. It creates those CRDs. And those CRDs is what the controller watches for. It says, hey, anytime you have this type of object, I want to apply a new state for it. I want to drive to that state. And another difference here is also with Terraform and with controllers and with any sort of infrastructure or software is it needs to take certain things in mind. It says, okay, what's my desired state? What's the data you just sent me? What's my current state? Because that's what the state of the world actually is. And someone like, again, what's my current state? My current state is off. And as soon as it's up, like, no, we need it off. Like this one's a little dumb, but it figures out current state and says, no, it's supposed to be off. And so, and then there's those steps in the controller that say, okay, I need to make desired state equal current state. And I'm going to keep looping until I get there. And that's where controllers are super powerful because in infrastructure is software in general, something like even just this, dumb Terraform controller that I just wrote. This is where something like that comes in a little more powerful because it's not using all your API requests. It's not constantly running. It runs when it needs to, but it runs immediately when it needs to. And it'd be great if Terraform actually did the reverse of this. If I actually if I always did a plan, like look at the buckets. If the bucket ever changes, reapply this. And that's what Kubernetes is doing. That's what the Kubernetes controllers are doing. It's going both ways, where it says, give me the data and also let me look at the current state. And if either of those change, then I'm going to drive towards my desired state.
So Justin, you mentioned CRDs real quick, but could you expand on that, what they are and what they do, please?
Yeah, Kubernetes, a custom resource definition is a CRD is any sort of thing that you can define with data. You can literally recreate all of the Kubernetes objects in CRDs if you wanted to. Like there's actually ideas to do that where Kubernetes has these native objects called a deploy, a replica set, a pod. These are things that just come with Kubernetes out of the box. They're part of the API, and you don't have to do anything to get those to work. Those are just there. Like a service, Kubernetes knows what a service is, but you can extend that. And you can say, hey, I have this different abstraction or a different way of thinking about things. So I want to define it a little differently. And Kubernetes allows you to just say like, okay, well, if you give me a certain amount of data to define what you want that to be, I can expose an API for you. And then all of your standard Kubernetes commands work from that new API. And so you give it an object, you give like a singular and a plural. And there's some different things that you define about it, like what kind of fields it should take to make a CRD. I don't know, if we don't have a stream on that yet, we should, because for sure, like creating a CRD from scratch is super powerful once you understand it, because a lot of things are building and extending Kubernetes that way. There's even another layer called operators, and operators take the CRDs and the controllers and it makes it operational. And so instead, like a CRD is just the spec. If I say I want a Dr. Pepper CRD, like I can easily make a Dr. Pepper CRD. Not a problem. I could say the flavor. I could say it's always available. This is just how we're going to run it. But nothing actually happens in Kubernetes until I have a Dr. Pepper controller. The controller subscribes to the Dr. Pepper CRD and then says, hey, take that CRD and do something with it. And whether that's something inside, I can create pods with it. I could order Dr. Pepper if it was available right now in this pandemic.
So,
by the way, I have to say, we're not sponsored by Dr. Pepper, but Dr. Pepper, if you're watching and you want to send Justin some Dr. Pepper, he would be most appreciative.
This can is currently empty. Yes.
Super low.
Great. So Justin, on that point, like, is it fair to say like there is a one-to-one relationship between a CRD and a controller that needs to be a controller for a CRD?
if you don't have a controller, nothing's going to happen. So I mean, you can use the Kubernetes API to store a bunch of data as CRDs and not actually have anything act on it. But you can also do that with native. Like if I create a pod in Kubernetes, but I don't have the scheduler running, nothing happens to it. Like it's just a spec that exists. The scheduler is what actually says, hey, I need to look at my nodes and I need to look at my pods and make sure every pod is assigned to a node. And that's like, you can go into Kubernetes, turn off the scheduler and manually do that. Like I actually have a bash scheduler on GitHub that's I wrote a long time ago, which is just I wanted to learn how that works. Of like I can take a pod spec and a node spec and then just I can figure those out manually and put. I mean, we used to do this with spreadsheets, right? Like I mean, who had spreadsheets for infrastructure? And you said which apps were on which servers, and that's literally what we're doing now with software. And it's not any different. It's just, oh, my database isn't a spreadsheet. My database is etcd. And I interface with that through Kubernetes. And so that's the controller helps you do things with it. But how you do that is up to you.
And so there was I think a really good question that came in from DarkSinge89 is how disruptive do you expect ACK will be in the AWS EKS world? Do you think it's going to become an adopted best practice, kind of like GitOps was? And I just want to say, you know, and I'll let you guys add more to this, but I do see this as being for the folks that want to keep Kubernetes as their source of truth, Kubernetes manifests as their source of truth for, you know, as much as they can within the AWS environment and the Kubernetes environment. This is going to enable them to do that. So you're creating resources in the cloud as well as in your Kubernetes cluster using the same language. So I personally think this is going to have a huge impact.
I think you're absolutely right. And then couple that with the way, like we saw Jay Pipes in his presentation on Monday, talk about how the code for ACK, or I like to say ACK, the code for ACK is generated. So anytime a service team updates with a feature, there should be like in a matter of, sometime between minutes and a few days, a new controller and a new, that code gets regenerated and published so we can start taking advantage of it. So we're cutting out any middle layers that customers may be suffering from today, like waiting on CloudFormation support, for example. You can go to running ACK and get immediate feature support. That's pretty cool. I think that's going to be bigger than people realize.
And for clarity too, AWS has, if you read the blog post, AWS has service operators, which is an old project that was done to kind of manually see how this would work and create those controllers and those CRDs and make it usable. But you're right, it wasn't generated code. It wasn't something that was maintainable without a lot of people time. And so ACK is kind of a reboot of that and something that is a much more maintainable and automatic way. So we can take those specs of what an S3 bucket should be, what a RDS instance should be, what a SNS, like those sorts of things, those services in AWS, and say, okay, we need to generate that now and build that code and controller just from the spec and not necessarily from someone handcrafting controllers and building them. And you can, especially for your own use cases, if you have something internally at your work that you say, I want something else to manage this for me. I'm sick of rebooting that server every day when I get an alert. Like you can build a controller that does those sorts of things. And for sure, like internal for your business, that's great. For us providing a service that someone else can adopt, we need it to be maintainable and automatic so that we don't have to go around to every service org and say, hey, you updated this field in an S3 bucket. Like I need to figure out how that works now for customers.
Yeah, and that is a good segue into the next question here, which is what is the difference between ACK, and the prior practices? And I think, so this is, I think, what Justin is kind of walking us through right now, where we started with, bash script to provision your environments and your resources. Then you kind of take this next step and you start to use Terraform or CloudFormation. But I'm going to let Justin continue because I think this is the path he's going down. Explaining this. So
and one of those crucial things is if you're using Kubernetes to deploy your applications, this makes a lot of sense because not only for the same interface, but for the reducing borders between teams, enabling a team to own their infrastructure, because if best practice is you're going to run stateless containers, but then you're going to say, well, if I need stateless containers, like I need state somewhere. So I need RDS or I need S3 or I need a queue or something like that. So how do you provision those things? And a lot of like currently it's, I deploy my Kubernetes stuff with Kubernetes manifests, and then I deploy the rest of the infrastructure over here. How they get dependency mapped and how they get, working together and deployed and made sure that they're all the same. Like I have to go bounce between different tools. And that's really hard cognitively for people to say, hey, my dashboard for my application is over here in Kubernetes, but my dashboard for AWS is over here. I need to manually connect those dots. And now we can merge those into one place. And so I could say, hey, Kubernetes, tell me what S3 buckets I should have and what applications I have. How they get tied together currently isn't solved. And just for clarity too, ACK is a developer preview right now. It's not even a beta. It's not an alpha. If you're a developer, please, come give some feedback, come join the code, but there isn't like a consumable thing that you can deploy right now. This is, testing documentation for how this code gets generated and how we do want to know how people are going to use it or want to use it. So we can kind of prioritize services and figure out just ideas that people have, because we don't know everyone's use case. But if you're not a developer and you're not familiar with, running make or running your own clusters and setting up IAM for those sorts of things, like there is going to be a gap currently with the developer preview.
That's a good point. I think even Brent and I were talking about that before. Like, let's make sure we mention it. And Brent and I didn't mention it, and you did. So thank you, Justin.
Totally.
It's a great point.
So, let's even, I think I'm in the directory. So I just did a clean checkout of the code right now. And let me switch over to my browser.
Switching over. Let's see, while you're doing that, if there's any other questions in the chat. We just, it's cool. We're Containers from the Couch is global. We have Italy. Hey from Italy.
We have Amsterdam as well, Edinburgh. I saw Edinburgh, Amsterdam. So folks from Europe, welcome.
It's pretty awesome.
Yeah.
So, okay, Justin, was this the screen? Are we good?
Yeah, we're good. So this is just the main landing page for some documentation. There's not a whole lot right here. We don't have examples for just like, I have a Kubernetes cluster already, let me just run it. This is still early, developer preview. Canada too. All right. So yeah, this is, but this is where the page is. There is documentation on what we're thinking. There's ways you can get involved and definitely there's mailing lists and issues. And then some default services that we're kind of focusing on right now. But where they're at is like, it's still, you need to build this code yourself right now. And you're going to have to build your own container and kind of run it. We're not necessarily going to have a whole lot to get people up to speed unless you know how some of this is going to work. So I am going to go I'll demo some of this here. Hopefully it works.
And below is the URL for the site that Justin is on right now.
So there's a contributor docs and there's testing. And this is going to walk you through 2 services that currently work to be able to build it locally. We're going to basically compile the code, create all the resources we need, the Docker container image, the CRDs, the Kubernetes manifest, and we're going to run a kind cluster locally, which is kind is Kubernetes and Docker. So it runs essentially the Kubernetes API locally on my machine. We're not doing it in EKS. We're not doing it other places just yet. This is, again, local only developer documentation. So give you some prerequisites. I'm hopeful this is going to work right now, but it didn't work this morning. This is very, we're doing a lot of changes. There's a lot going on just with some of the targets of like make files and how it's working. And also I've messed up my computer more times than once. So doing this on multiple different machines has been interesting as well. But this is, kind of walking you through, we're going to say what service we want to build. We have a target to actually build that. So I'll just show you make help because this is like my first contribution to the repo of like, hey, I don't know what any of these make targets do, and like no one does, and so let's just like give some feedback on this is some help output and what each make target's going to do. I think I already have.
So do you want to share your terminal instead of the page?
Oh yeah, I do. You're right. Hold on.
Okay. Let's get back and
that was me. I actually need to set up OBS so I can have just part of my screen always shared and anything in that window works. But I'm not there yet.
It's a constant learning process. So while you're doing it, there was a question. I think I'm sensing a little break here from Techie Stories. By the way, I don't know if we've even said hi to Techie Stories. She's a regular, so hey, Techie Stories, welcome back. Can you describe the difference between Terraform and configuration management? CMS, I always just content management. Configuration management services such as Chef, Puppet, Ansible. Who wants to take that?
I think Terraform is config management. Frankly, I think that it might be operating at a slightly different layer because Terraform is very often used to provision infrastructure, whereas Chef, Puppet, Ansible tend to be used to configure, the infrastructure once it's up, like the operating system. But there's so much overlap that I would still consider them all config management of some sort. Like for example, Terraform, you can configure user data that runs on boot for your EC2 instance, and then that user data you might be able to initialize Ansible and have it do an Ansible run, on first boot to further configure the operating system when it comes up, or Puppet or Chef, etc. So I kind of think of them all about the same. So she says true, but the actual state perspective. So that's where Terraform maintains its state in a separate file, and there's various ways of dealing with that, but that state is just constantly being, every time you make a change to Terraform and run it, then it goes and it writes anything successful that it has changed. It writes into that state file so that it can track, what it has accomplished. And as far as I know, there's not an equivalent to that in Puppet or Chef. There might be at a local host level, for example, but like what cookbooks have been applied or something.
And I think that's at the Chef server level. Like you have a main Chef server that's kind of tracking the state of everything. Whereas like with Terraform, it's just it's one file for one environment stored somewhere. Git S3.
Which is sometimes hard to separate, right? Because the traditional config management tools usually have a scope of a machine. Whereas Terraform has a scope of an environment, whatever that environment may be. But Terraform gets tricky because if you say my environment is all of Amazon, then it gets hairy because you have your VPCs declared with your applications, with your S3 buckets, and the VPCs hardly ever change, hopefully. But your applications are deployed frequently, and your load balancers are declared. Like those sorts of things, separating out what that environment is of that's what state should be where becomes up. Is your decision to say, hey, this team is responsible for the VPCs, so I'm going to let them handle that Terraform code. This team is responsible for their applications and load balancers, so they should do that, and they can iterate independently of each other and drive that state.
And then there's Ansible that can operate at both levels and has basically no state, and you just run it and it goes and rechecks everything every time just to make sure that it's set the way that it's defined in the code.
Right. Salt Cloud also has a similar thing. They do have state for, like a centralized, Salt server, that kind of stuff. But all of those tools started to expand out and say, hey, we needed more than machines. But it's not necessarily, the same. It didn't take the first approach of environment is an abstract thing. Machines are maybe I do something to it. But even Terraform usually has you provision a machine with Bash or Puppet or Chef. Like it just says, hey, I'm not responsible for what's on the machine, so I'm going to let something else handle that. And that's fine.
Yeah, that's a good point.
Yeah. All right, let's continue on.
Before I go much further, I just need to set some environment variables so that my IAM permissions will be correct, hopefully, for this controller to actually create an S3 bucket for me. So there's a few things in the docs, and I don't know why this one always fails for me. There we go. So I need to make this trust policy of saying, hey, my user can assume the role of this Kubernetes user, which I already created. Again, these are developer previews, so I don't actually need to run some of these commands. Like I already have this trust policy set up for my user, and giving the full access in my test account. Please don't do this in a production account. Don't run developer preview things in prod. It's not going to work out well.
Amen.
And then I need this AWS account ID, which is getting, exporting for the controller to use and say, hey, this is what I actually need to run with this controller as. And so I'm going to cross my fingers and hope this actually works now. Kind test.
Whilst you're doing that, one point that Jay made, Jay Pipes, who's our senior engineer, who's been working on this for a while, he made during our container day was that your IAM policies and the IAM setup that you do for using this has to be done for now within AWS. So what you see right now is just in using AWS commands, but then preparing the whole IAM roles and users within AWS IAM and not within Kubernetes.
That's a great point. And also watch, I think it was our first talk, or our first Q&A, live Q&A from our container day earlier in the week. And Jay Pipes went into detail as to some of the implementation details, why they chose certain routes and why they did certain things. So if you want to get even deeper, that's a great video to watch.
Totally.
So this make command is going to test all the code. It runs all the tests, and that's going to create a kind cluster for me. And then it's going to build the S3 container. And this is actually where it always failed for me. And I have a weird problem right now with Docker on my machine that this failure kept happening. And now that I think about it, I know why it worked on a different box.
It's probably more disk space or something, like that. I don't know.
It was actually a problem. Originally, it was a problem with DNS resolution inside the container trying to do a go get. So go get inside the container couldn't resolve GitHub. And it was a local thing that I broke in Docker on this system. So if this doesn't work, I actually can, let me do it in parallel. So we can run it both, right?
Yeah.
Box. Oh, it's not installed.
And so what are we doing in parallel right now?
I'm just going to try to create this kind cluster twice because this separate machine, this EC2 instance that I had, this one actually didn't have Docker broken. So we'll see if that Docker container works, but I have a feeling it's going to fail on me again. If it works, we're good. So I'm just going to export these variables again.
And again, just while you're doing this, just to recap, we have been talking about AWS controllers for Kubernetes. Justin's been walking us through that today. He had a great prop once again, and this time he truly did an unboxing on the show. He didn't just unbox ACK, he unboxed a package that had his prop for the demo.
I unboxed a box, yes. This was very meta.
Oh my gosh, yeah, so meta.
And Brent's reaction, I think, was priceless there.
I mean, I've never seen that before. And like the fact that someone would actually manufacture such a device is just hilarious to me. But I love it. And it is the perfect prop for illustrating what a controller does. So like, that's amazing. But yeah, it all just hit me way too hard and I couldn't control my laughter. So
right here, this is my Docker container keeps failing to build. It's a DNS error on my local box that I need to fix. But let's see, I'm almost to the point of, does this work?
And just, in the short time working with Justin, I've learned that he loves to do everything build it from scratch. He loves Linux. So whereas me, I just want whatever. I want the easiest operating system. Justin's a real professional. He builds everything from the ground up. And by the way, Brent, I don't know if you saw earlier, there was a mention of we are like the We are Twitch's answer to Starsky and Hutch from Anton, and I really liked that. I just want to know who's Starsky and who's Hutch. That's all.
Yeah, well, so I hate to admit it, but I never watched Starsky and Hutch, so I like actually don't. I mean, were they like PIs? I can't remember.
They were just they were cops, but they were like kind of wild and crazy.
Okay.
One was like really serious, and the other was kind of reckless. I've only seen the movie. I didn't watch the series.
I've got to be the reckless one in that scenario.
Maybe that would be the Owen Wilson character. Very good.
Oh, perfect. Yeah.
So will this be added to the EKS workshop?
No, but we will add this video to Containers from the Couch, and I think in a few weeks we'll probably add a different tutorial to EKS Workshop about this. So I'm not saying no ACK won't show up on EKS Workshop, but it may not be this particular walkthrough necessarily, if that makes sense.
Maybe as it matures a little more.
Yeah, exactly.
Then we'll see it there.
Yeah. We want to get a good demo that has like 2 or 3 services that we can like, stitch together and make them all work simultaneously. So
how's it Justin?
This repo I hadn't pulled from the upstream source, and so the make files had changed from a few days ago. So it was giving me an error, but now we'll see if this actually builds. It should, again, it's going to create that local kind cluster. It's going to build the container. It pushes that container into the kind cluster and then deploys some CRDs and some manifests to say, hey, can you make this actual S3 bucket for me? So we're just testing one simple S3 buckets to show off how it works. And there, if you're good at the code, like want to read through the code, there is like a scripts directory where you can run a lot of the stuff manually if you don't like make or want to understand the steps. We tried to, as much as possible, help with some of the output. If you go through and read it, it's a lot when you read it the first time. But once you kind of like know what to look for, like this will show me, oh, I just need to look for this script command, and I could run this manually if I wanted to, if something fails. But again, my local machine DNS inside of Docker has been broken for a little while, and I really need to figure that out. But the easy thing was just create a VM and do everything from there. It also had more RAM and cores, so I can't complain too much.
And Techie Stories, another question, is ACK more for larger deployments? I mean, I would say no. I think it really is for if you want the experience, again, and I'm repeating myself, but if you want that experience of Kubernetes manifest YAMLs as your source of truth for your environments, small or large, I mean, ACK empowers you to do that and enable
maybe just say, or maybe like let's just point out that when it comes to provisioning and managing AWS infrastructure, ACK, and doing it a Kubernetes way, ACK is going to be a terrific answer for that scenario. And it might be just one SQSQ, or it might be like a whole slew of stuff that you need in order to enable your app. So yeah, I think you can go large or small, but the key decision point is, am I provisioning AWS infrastructure to support this particular application or deployment?
Bingo.
One thing that I like is ACK is separate controllers. Look at this. I have a role wrong here. I missed the :R, so that was probably me copy pasting something bad. Let's make. But because it's separate controllers, you could pick and choose which pieces you want. So like you don't have to take all of AWS services and run all 160 controllers. Like, hey, all we care about is S3 buckets and RDS or SNS. Like you can do just those, which is actually really neat.
Yeah, that is cool.
And we're gonna do it one more time.
Okay.
And this time, if this works, it's gonna be golden.
We have plenty of time.
5 minutes? Yeah.
Maybe a little less, but all right. All right.
Do we have someone after us today, Adam? Do you know? Do you remember?
I don't. Let me go find and determine if that's the case.
I'm afraid to touch my computer otherwise.
Yeah, don't you dare, or else you'll be frozen.
Yeah.
But
Yeah,
really, the dead air is terrific. So
one other thing that I think is also cool about not all just like independent controllers here, but you can namespace these controllers. And so like if one team has their own S3 buckets, like you can have a namespace for, or a Kubernetes cluster or whatever, that they have their own controllers in, and you can also deploy these clusters somewhere, the controllers somewhere else. And another team can have, like, I don't need to see, front end doesn't need to see back end's S3 buckets, but you can have multiple clusters, even different namespaces with the controllers running, and they can manage those things separate. And you could say, hey, I want the view of my S3 buckets under this namespace. And Kubernetes has those segmentations just built into it with namespaces or separate clusters and kubeconfig files that make some of those things really easy to do.
Do you think it's going to include the namespace as part of the bucket name?
No.
Okay.
It's not current. That's not currently how it works. But if you want it to, like, I mean, again, give feedback on the repo. If you say I need namespaces, there's actually the new tiered namespaces, which is a new feature, which is kind of interesting, where you can have a namespace inherit things from another namespace, which would be interesting to be able to say, like, hey, I do need my buckets to always have some sort of attribute or some sort of name on it, more of a attribute based control.
Mm-hmm.
Oh my gosh, is it going to work?
That's looking promising.
Yeah. Whilst it's happening, Justin, could you run us through the scripts directory in the GitHub repo? I was just looking through it, and I don't know whether that's a good idea. You can decide.
Wait, I think it's creating, and we're gonna see it. This is the final. Like, I always got an error here, and we'll see if that bucket actually gets created.
This is going to be the buzzer beater here. This is going to either win.
Is it going to work? Is it going to work?
User Mew had commented CDKs and ACK golden.
I have a bucket.
Nice.
Nice.
Look at that.
Cool.
So, and we can also, because again, this created a local kind cluster. I can see. Whoa, let's make that just a little bit wider. We can see our controller running, and then we can also get CRDs and namespace ACK system. We have a CRD there.
Is there a bucket object?
And here's our objects inside the API of what we. Whoa, that was a lot. JSON at the top. Those are all annotations. So we basically say, here's our group. Here we want a buckets. It has, this is the actual definition of what the CRD is. And so we say it's going to be a bucket. You can have buckets. You can have a bucket list, and it's namespace. So again, you can have multiple people deploy buckets in different namespaces. And there's a lot of other things in here. So if I
there was a question about could something like EKS Cuddle be able to use ACK to help set up infrastructure, or is that totally out of scope with ACK?
I think we talked about this on Monday, and this was something that I even noticed Bob chimed in on, Bob Weiss, the GM for Kubernetes at AWS. And Jay was kind of, apprehensive, but basically creating a CRD that can build EKS clusters, an operator that can build EKS clusters, that's on the list. So it hasn't happened yet, but it's definitely on the list of things to do. So eventually it wouldn't be using EKS control, but it would be using, an operator using ACK to build more EKS clusters from there. And then if you couple that with a GitOps approach or something like that, you might even be able to have it go, provision the cluster and join a GitOps repo, download all of its stuff that it needs to be running, and you could have a completely deployed suite of applications on that cluster, 100% hands off. So this is all future, it's not today, but like it's totally, you can see it on the horizon.
And that's actually, a big idea behind the cluster API is a project within Kubernetes that literally has a Kubernetes meta cluster that manages your other clusters. And that is absolutely something that they've been driving to say, hey, what if you need clusters multiple places? Or what if you want a declarative interface to have those things? And ACK will be able to do that locally inside of, to create EKS clusters. Cluster API is a lot more generic, where you can add providers that say Raspberry Pi on-prem, that kind of stuff. I know we're actually at time. I don't remember how to actually print out the buckets, but we have one that exists. If I AWS S3,
just LS too, right?
oh, what is? Oh, it's
LS, yeah.
What? Or that.
Or that.
Where'd you go? Oh, but then I need a query. I got it. I'm gonna do it.
AWS S3 LS is just pretty simple.
Right.
I know you're fancy.
There you are. Wait. Oh, it deleted it.
Hey. Oh,
it deleted
it. It deleted
for
it
the
when
test.
it
For the
created
test, it deletes it after it creates it.
Oh, nice.
Yeah, it deleted it when
Wah,
it created.
Well, that's
see
handy.
the controller is like, no, like we no more buckets.
All right.
That's why I couldn't list buckets, because it deleted it.
Yeah, it said that on the output as well. So yeah.
Well, I don't read.
All right. What do you think? Think it's time to wrap?
I think so. Yeah, for sure.
It's great.
We are at time, but what did we see? We saw managing AWS infrastructure very early, but still it happened, and we did it using nothing but kube control and some operators and some CRDs. So that's kind of amazing. I mean, this is going to be huge in the very near future. So I'm really looking forward to it.
Yes, and we will share the link to our YouTube channel in just a moment, but you can also go to containersfromthecouch.com to get all the content that we do from the show. The same day we upload it to containersfromthecouch.com.
Exactly.
So other than that, thank you everybody for joining us today. We will be back tomorrow, and we should have our friend Jesse Butler tomorrow.
That's right. Jesse's going to walk us through managed node groups and customizing those tomorrow. So really looking forward to that. And until then.
Thanks, everybody.